these equations are going to be a little bit more involved. All right, and may require more steps than we had to use last week in order to solve equations. So the first thing I would like to do is let's go to our textbook here. And let me just bring that up here. All right, so I want to go to page 119 in our textbook, and I want to show you something here. All right, so we're going to solve more general linear equations today. And on page 119, here is a shaded box that consists of guidelines as to how we should approach more advanced linear equations. Step number one is we should always try to simplify both sides of our equation if possible. And to simplify both sides of our equation, that may involve using the distributive property to remove parentheses. We may have to combine like terms on both sides first. Okay, and once we completely simplify both sides, then step two kicks in. That is where we use the addition or the subtraction property of equality to separate our variable terms on one side of our equation versus the constant terms on the opposite side. Once we have our variable terms separated on one side of our equation versus the constant terms on the opposite side, then we need to either use the multiplication or division property of equality to get the variable all by itself. And last but not least, if you have extra time, you can always check your answer back in the original equation and make sure that it does satisfy the original equation, although I'm not going to require that you check your answer. Okay. So in general, these are the guidelines that we are going to adhere to as we learn how to solve equations that are a little bit more advanced and require more steps. Okay. So again, these guidelines are on page 119 in your textbook, which is section 2.4. And so we are going to tackle 2.4 and 2.5 today. All right. And the moral of the story is solving equations today. Okay. All right, well, let's take a look here. Let's go to my DocCam here and let's begin. All right, so I have several equations lined up that I would like to demonstrate. Please do account for these in some way. Here's an equation that we want to solve for the variable x. And the first thing we're going to have to do here, is, well, we would be tempted to go inside the parentheses on the left side of our equation, but there's nothing we can do inside the parentheses. And we don't have any distribution to do here because we really have just like a 1 out front. So the next step is just to combine like terms. Are there any like terms in this equation on the left side that should be combined? Anybody?
1x and 5x.
All right, we should combine these like terms of x here. So 1x plus 5x combined to give us 6x. Right? Now the left side cannot be simplified anymore. These are not like terms. You cannot add 2 to 6. The right side's already simplified. So now it's time to separate the variable terms on one side of our equation versus the constant terms on the opposite side. And I like to have my variables on the left side of my equation. That's my preference. So I'm going to have to move this 2 over to the right side. Now, how do I move a positive to the other side of the equation?
Subtract.
So we're going to have to subtract 2 from the left side, but we're also going to have to subtract 2 from the right side of our equation. in accordance with the subtraction property of equality. Notice the 2's add up to 0 on the left side or cancel out, leaving you with 6x. And on the right side of our equation, we have 20 minus 2, which is 18. Now, ladies and gentlemen, one last step to get the variable by itself. We need to employ the division property of equality. We must divide both the left side and the right side by 6. The 6's on the left side reduce out to 1's, and 1 times x is better known as x. And 18 divided by 6 on the right time is our solution. On the right side, that's your solution to this equation, x equals 3. Any questions how we solve that equation for x? So first, we simplified the left side as much as possible. Then we separated our variable terms on the left side of our equation and our numbers or constants on the opposite side. And then we got the variable x by itself. All right, that one sit well in your mind.
Yes.
Let's try another one. Okay, let's try this one. Negative 2x minus quantity 4x minus 8 equals negative 1. Here is a first degree or linear equation. We want to solve for x. It looks like the left side. Yes, this is being recorded. It looks like the left side, ladies and gentlemen, is in need of simplification. Notice we have a minus sign that precedes this set of parentheses here. And so to get rid of these parentheses, we're going to have to distribute. And when you got just a minus sign in front of a set of parentheses, you should really think of it as being like a negative 1 that needs to be distributed in. So we're going to distribute negative 1 into both these terms. So we're going to have negative 2x. Negative 1 multiplied by 4x is minus 4x. A negative 1 multiplied by a negative 8. A negative times a negative is a positive. So negative 1 times negative 8, positive 8. And we got our equation down to this. Combining like terms on the left side of our equation, negative 2x minus 4x. What's negative 2 subtract 4? It's really negative 2 plus a negative 4, which nets us a negative 6. So negative 2x minus 4x is a negative 6x. Now it's time to continue to separate the variable terms on the left side versus the constants on the right side. So I have to move this positive 8 over to the right side. How do we move a positive to the other side?
Subtract.
We have to subtract off 8 from both sides. The 8's drop out on the left side to 0, leaving you with negative 6x. And on the right side, negative 1 subtract 8. Negative 1 minus 8 is really negative 1 plus a negative 8, which nets us a negative 9. Finally, to get x by itself, we have to employ the what? Division property of equality, dividing both sides by negative 6. Now to divide the right side by negative 6. I'll continue up here. And negative 6 divided by negative 6 is negative 6x divided by negative 6 reduces down to 1x or just x. And a negative 9 over a negative 6 is as good as being a positive 9/6. And can we reduce 9/6? It's down to 3/2. Ladies and gentlemen, that would be your solution to that equation, 3/2. Any questions how we solve that equation for x? So first, simplify the left side as much as possible, and then you start to separate variable terms on the left side versus constant terms on the opposite side. And then ultimately, you got to get the variable by itself. Okay.
I have a question.
Yep.
So whenever we have a problem with the number outside of the parentheses, we always distribute.
Yeah. This is a minus. It's like a -1 that needs to be multiplied by 4x and minus 8. So we're going to distribute the -1 into both these terms here. You see that? -1 times 4x is minus 4x. -1 times a -8 is a +8. Okay. Does that make sense?
I have a question also on fractions. So if for instance, the one we just did, a -9 over -6, say it was a -9 over +6, no matter where that negative sign is it always going to be, you just move it in front of it?
You can if you want. I mean, if you had a solution, let's say you had a solution of -9 over 6, you can really put the negative sign anywhere. You can attach it to the numerator or the denominator, or just bring it outside the fraction. These are all equivalent, okay?
Okay.
All equal to each other.
All
We
right.
don't have that issue here because we have a negative divided by a negative, which is really what, a positive, correct? A positive. So
I found some of my answers on when I was doing my homework, I was missing a negative sign because when I divided it turned into a positive.
I have to see what's going on.
Like I'd have to find one. I don't have it off the top of my head.
All right. Well, when you find one, just let me know, okay?
Okay.
Now I'll take a look and try to clarify that.
Okay.
Any other questions, ladies and gentlemen, about this equation here, how we solve for x here? The key is you got to do a lot of practice. I mean, you know, when you practice solving a lot of equations, you're going to get better. This is going to start to seem more natural as to what's going on. All right, but you really just have to spend a little bit of time and doing a lot of practice. All right, and it will start to come into focus, but it's going to take practice. All right, and for some of us, probably more practice than others. But you know, we got to do what we got to do. All right.
So where do we get the practice from?
Well, textbook homework, that affords you an appreciable amount of practice. All right. If you need extra problems to do out of your homework, and by the way, I do attach the solutions to your homework. You're aware of that, correct?
Yes.
So, you know, I just like usually assign odd problems, but if you want to do some even problems, they're there, they're waiting for you, you know, and you got the answers, the solutions also to check your answers. So I would probably, if you need more practice, do the even problems also. Okay.
Thank you.
I think by doing the odds and the evens, that's going to afford you a lot of practice. Okay. If you still can't get enough practice, let me know. I have more books of which I can dive into and make sure that you never run out of problems. Okay.
Thank you.
But usually students, when it comes to education, you know, they're usually good. I mean, every time I offer more problems, they say, no, I'm good, I have enough. They don't want any more for their money. So but, just try this one. But if you want more practice, I can dredge up more practice. Just let me know. I'll be glad to give you more practice if your textbook's not affording you enough practice. All right. Well, we'll try to solve this one for x. It looks like the left side is in need of some serious simplification. A lot going on the left side. There's really nothing going on the right side. We just have a number 2. So what would we have to do here on the left side? There's nothing we can do inside the parentheses. These are not like terms. These are not like terms. So how are we going to remove these parentheses? What property do we need to use? We're going to have to use our what property to remove these parentheses?
Distribution.
So we're going to have to distribute 4 inside the parentheses here. 4 times x is 4x, plus 4 multiplied by 1 is 4. Here, a positive 3 has to be distributed in. Plus 3 times 1x is 3x, plus 3x. Plus 3 times a negative 3, careful, a positive 3 multiplied by a negative 3 is a minus 9. Now we could write plus a negative 9, or we can just say minus 9. And on the right side, we have 2. Do we understand how we distributed, first of all, on the left side? Okay, any like terms on the left side that need to be combined? Any like terms?
4x and 3x.
4x plus 3x. What is 4x added to 3x? 4x plus 3x is 7x. And we have these constants that need to be combined. What's 4 subtract 9? 4 subtract 9
-5.
minus 5. Now you could say plus a -5, or you can just say -5. I will just say -5. On the right side, we have just 2. All right, so we got our equation down to this now. We're getting closer. What do we do next? Anybody? What do we do next?
Add 5 on both sides.
Yeah, we want to separate our variable terms on, let's say, the left side of our equation and our constant terms on the right side. So we got to move this -5 to the other side. And the only way you legally algebraically do that is you must add 5 to both sides of your equation. So we add 5 to the left, we add 5 to the right. And we need to do that because the addition property of equality says we must do that. The 5s on the left side add up to 0. -5 plus 5 is 0. The 5s are gone. And we're left with 7x. 2 plus 5 on the right is 7. All right, what do we have to do now? One last step.
Divide 7.
Divide.
Yeah, since it's 7 times x, we want to get x by itself, we have to employ the division property of equality. We must divide both sides by 7. Got to divide the right side by 7 also. 7x divided by 7 reduces down to just 1x, or x. And 7 divided by 7 on the right side is our solution, which is 1. Ladies and gentlemen, you are looking at your solution. X must be equal to 1. That's your solution, 1. All right, any further questions on that one there? Just making sense how these problems are going here so far.
Yeah.
Okay. All right. Practice, practice, practice. That's the key. Let's try another one. And if you feel like you're starting to slip, you know, I'm always here to help. So you can always, you know, get in touch with me, and if it means arranging a one-on-one session, we'll do that. All right, here we go. I want to solve this equation for x. What would be the first move?
The distributive property.
Yeah, we have to simplify our left side a little bit. Notice we have parentheses again. Nothing we can do inside the parentheses. These are not like terms. But ladies and gentlemen, we have to remove these parentheses, and therefore we're going to have to distribute. What kind of a 2 is going to have to be distributed in?
A negative.
Yeah, it is going to be a -2. I mean, if you want to change the subtraction to addition, go ahead. You can change subtraction to addition, but it would be plus a -2 that needs to be distributed in. So I like to avoid that. Just think of this as being a -2 that must be multiplied in. So what's -2 times 1x? -2 multiplied by a 1x. I will say -2x. What's a -2 being multiplied by a +2 over here? That's a -4. On the right side of our equation, there is no simplifying necessary. It's already simplified. Back on the left side, we must combine like terms to further simplify the left side. What's 1x subtract 2x?
One.
-1x. All right, what would be next now?
Would you combine?
Like terms.
Well, we can't combine these terms because they're on opposite sides of the equation. We're at a point in this problem where we're going to have to separate the variable terms on the left side versus the constant terms on the right side. So how do we do that? How do we make that happen?
Subtract 4. I mean, add 4.
Yeah, you can add 4 to both sides. That will bring this constant term 4 over to the right side to join the -2. The 4's drop out on the left side to 0, leaving you with -1x. And on the right side, we have 1x. Well, what's a -2 plus 4? Plus 2. All right, that was a good move. That was legal. Now, what's next, do you think? What's the next logical step?
Divide -1.
let's not divide both sides yet by -1. Let's continue to separate. I have my constants on the right side, but I need to move this variable term over to the what? Left side. So how do I move a positive 1x to the left side of my equation?
Track.
Subtract. So we're gonna have to subtract 1x from the left side and the right side. Combining these like terms on the left side, -1x subtract 1x. What is -1x subtract 1x?
Is 0.
Negative, whoops. What's the- Wait a minute, what just happened? Hello?
Yeah.
Hello?
Can you hear me? Okay. I'm not sure what happened. Okay, wow, whatever. All right, so what's -1x minus 1x?
Negative 2.
That would be a -2x, correct. These 1x's on the right side dive out to 0, right? They cancel out. 1x minus 1x is 0x, 0. We're left with 2. Okay, ladies, we got it down to this. What's the one last step now, solving for x?
Now divide.
Now we divide both sides of the equation by what?
-2.
Yeah, I'm trying to get rid of this -2 here. Not 2x, just -2. Now, what's -2x divided by -2? Does that reduce it down to just what, 1x? 1x or x? Now, what's 2 divided by -2?
-1.
There's your solution. X must be equal to -1. Okay, so that equation has been solved. All right, -1's your solution. Any questions, further questions on this problem here? -1's your result. That's your solution. Let's see here. All right. Try another one here. All right, we'll solve -5 times 4t minus 3 equals 2 times 1 minus 8t plus 11. We will try to solve this equation for t. What would be the first move here?
Distribute.
Yeah, on the left side, there's nothing we can do inside the parentheses. These are not like terms. So we have to come outside the parentheses and we run into this factor of -5. This -5 is going to have to be distributed into both these terms here. -5 multiplied by 4t is -20t. -5 multiplied by a -3, a negative times a negative is a positive. 5 times 3 is 15. On the right side, nothing going on inside the parentheses, cannot combine these. These are not like terms. We have to distribute the 2 inside the parentheses. 2 multiplied by 1 is 2. 2 multiplied by a -8t. A positive 2 times a -8t is a minus 16t. 2 multiplied by -8t is minus 16t. We got this plus 11 here. Don't multiply the 2 by the 11 also. The 11 and the plus 11 is not inside the parentheses. It has nothing to do with this factor of 2 here. Only 1 and minus 8t do, okay? There you go. Nothing left to do on the left side as far as simplifying is concerned. On the right side, we have a little bit more simplifying. Combining like terms, what's 2 plus 11 here? 2 plus 11. 13 minus our 16t. Nothing left to do on the right side as far as simplifying. It's time to now begin to think of separating, ladies and gentlemen, the variable terms on the left side versus the constants on the right side. How do we move in that direction? Anybody? Time to separate.
Add 15.
Add 15.
I kept it minus.
Yeah, we would have to minus the 15 from both sides to move the 15 over to the right side, correct? We're gonna have to minus 15 because we had a -5 times a -3 is a plus 15.
I did plus a negative, that's why.
-5 multiplied by -3 is a plus 15. So we can either add a -15 to both sides or just subtract 15 from both sides. I'm just going to subtract 15 from the left, and I will have to subtract 15 from the right. The 15s on the left side cancel out to 0. 15 minus 15 is 0, and we're left with -20t. On the right side of our equation, what's 13 subtract 15? What's 13 minus 15?
-2.
Yeah, it's really 13 plus a -15, which is a -2. 13 minus 15 is a -2. And then we got the minus 16. All right, we got to continue to separate the variable terms on one side versus constant on the other side. So what's the next move now as we continue to do that?
A division.
Okay, what would we add to both sides?
16.
You are correct. We're going to add 6t to both sides. So we're going to add 6t to the left. We add 6t to the right. Combining these like terms of t now on the left side, -20t plus 6t. What's -20 plus 6?
Is it 6T or 16T?
Yeah, 16.
6t. It's just, wait a minute here. We had 16t up here. I apologize. That's minus 16t. So we're going to add 16t to both sides. I do apologize, ladies and gentlemen. Yeah, it's minus 16t. Yeah, keep bringing it down. So we add 16t. So what's -20t plus 16t?
Negative.
-4t equal to these 16t's drop out to 0, and we're left with -2. All right, one last step. How do we get t by itself?
Divide
Both sides by what?
-4.
You are correct, by -4. -4t divided by -4 reduces down to 1t, or just t. And -2 divided by -4, -2 divided by -4 is as good as saying a positive 2 over 4, correct? Because a negative divided by a negative is a positive. Can we reduce 2 fourths? Reduces down to 1/2. You are looking at your solution. T must be equal to 1/2. So the solution to that equation is 1/2. Any questions about that one? All right, are you ready for classwork number 1? All right, let's try classwork number 1. Classwork number 1. Please, in your subject line of your email, by all means, put math. Put a space, just hit your space bar and then 082. Classwork 1, this is September 27th. I want you to solve these equations. Number 1. Number 2. Number 3, last one. There you go, ladies and gentlemen, 3 equations. See if you can solve those. And we'll come back and take a look at those. Classwork number 1. Okay, problem number one. Anybody get a solution for that? Number one.
Y equals 1.
Y equals what?
1.
1.
I
Anybody
got
else?
2.
You got 2 for number one?
Yeah, I'm not sure though.
All right, I'll listen. Anybody get anything different than 1 or 2?
I got -6, but I'm totally lost.
No, you got -6. Okay. All right, well, let's take a look at number one, ladies and gentlemen. First, we're going to have to what? Distribute the 5 on the left side, right? So 5 times y is 5y plus 5 times 2 is 10. Whoops, hold on a second, right here. And then we got to distribute the 4 inside the parentheses. 4 times y is 4y plus 4 times 1 is 4. Did we at least get this distribution correct? Right here?
Yes.
Okay, now it's
Yeah.
time to separate. What's that? Somebody did not get this, or?
I already got it.
Okay, now it's time to separate the variable terms on the left side and the constant terms on the right side. To do that, the next move I did, and there's different ways you can proceed from here, but I decided to subtract 10 from both sides. Subtract it from the left, subtract it from the right. 10
Wait a
is
minute, is that a y plus 3 or 2 in those parentheses?
This is y plus 2. What? This
What's
is
the
y,
what's the second one?
this is y plus 1 here.
Oh, I wrote the problem down.
This is y plus 2. This is y plus 1. Okay. I subtracted 10 from both sides. 10s drop out on the left, leaving you with 5y. 4 subtract 10. What's 4 minus 10? That's 4 plus a -10, which is what, a -6? Continuing to separate, I now need to bring this positive 4y over to the left side of my equation. How do I move a positive term to the other side? I need to
Subtract 4y.
subtract off 4y from both sides.
I cannot believe I got that right.
5y minus 4y is 1y. And yeah, the 4y's disappear there and you're left with -6. So you did have that correct there. Nice job. Solution should be -6, ladies and gentlemen. If you did not get that, do you see the error on your paper? Do you see where the mistake occurred?
Yes.
Okay, and that's what it's all about. We want to turn this into a learning experience so that, you know, we don't make the same mistake, you know, another time around. So it's very important to try to, you know, learn something from our mistakes. And it's no fun. I mean, you know, we don't like to go back and look at our mistakes because, you know, it's frustrating, but that's how we learn, unfortunately. I mean, we have to learn from our mistakes. But if we never learn from our mistakes, we're going to keep making the mistakes, and that's not a good place to be. Okay. All right, so -6 is the only solution to that equation. Number 2, anybody get a solution for number 2? This equation right here.
2/3.
Okay, you got 2/3.
I got a -1/3.
All right, 2/3, -1/3. Anybody else get anything different? All right, so I'm hearing 2/3. I'm hearing -1/3. Let's see if we can begin to address this equation. The first thing I did here, is I distributed a -2 inside the parentheses here, and I distributed the 3 inside the parentheses here. So -2 times 3y is -6y. -2 multiplied by 1 is -2. 3 times 1 is 3. 3 multiplied by a -6y is a -18y, and we got the -9. Did we at least distribute correctly? Look on your
Yes.
paper.
Yes.
Okay, so we're off to, at least we're moving in the right direction. I mean, it could be worse. All right, then what we want to do is, notice the right side is in need of simplifying a little bit. I have this 3 that really should be combined with the -9. And 3 subtract 9, what is 3 subtract 9?
A -6.
And it should be a -6. So therefore, when you do 3 minus 9 on the right, you're left with -6 minus this 18y. And the left side is still this. It's time now to separate. Since we cannot further simplify either any one of these sides, it's time to separate the y terms on the left from the constants on the right. And there's one of four ways you can proceed from this point onward. But what I chose to do is add 2 to both sides. I wanted to move this 2 over to the right side to join the -6. You do so by adding 2 to both sides. The 2's drop out on the left side to 0, leaving you with -6y. And on the right side, -6 plus 2 is -4. Continuing to separate, we got to bring this -18y over to the left side. The only way you do that is, what's the inverse of subtraction? You must
And
add 18y to both sides of your equation. This step is showing that I am adding 18y to the left and also adding 18y to the right. -6y plus 18y nets us with what? Nets us with
12y.
y. And on the right side, these y's disappear to 0. They cancel out. They're gone, leaving you with -4. One last step now is to divide both sides by a +12. And when we do that, divide both sides by 12, our result is going to be y, or 1y, is equal to -4/12. But -4/12 reduces down, ladies and gentlemen, to what? -1/3. Do you agree?
Yep.
Yeah.
Nice job. I did hear somebody got -1/3. Congratulations. That's quite an equation. We come a long way since last week. So we really have become more advanced in our ability to solve multi-step equations. If you did not get -1/3, do you see where the error occurred? You see where the error occurred on your paper? Okay. The key is, if we made a mistake, we want to go back through. That's why it's important to show your steps, so you can go back through and troubleshoot or pinpoint where the mistake occurred. Okay. All right, good. Number 3, ladies and gentlemen. Number 3. Anybody get the solution to number 3?
I got a -2/3.
-2/3. Did anybody else get -2/3?
I had trouble with that one.
Okay, so some of us got it, some of us are a little mystified by it. All right, now let's begin to take a look at it. When you have a negative sign that precedes parentheses, it's really like, you can think of it as being like a -1 that needs to be distributed into the terms in the parentheses. So I put like a -1 here. Likewise, this minus here, I put a -1 that has to be distributed in this set of parentheses. Likewise here, I put a -1 that has to be distributed in here. So what's -1 times 6x? That gives you -6x. -1 multiplied by 2 is -2. -1 multiplied by 8x is a -8x. -1 multiplied by a -3 is a +3. On the right side, we got the 8. Now, what's -1 times 5x? -5x. -1 multiplied by 1 is what? -1. Did anybody get down to here at least? Down to here?
Yes.
No, I need help. When
All
we're
right.
dividing,
Stop.
okay, so like the first part, -1 times 2, I copied that down and put plus -2.
You can say plus a -2. There's nothing wrong with that.
Okay.
I like to, instead of saying plus a -2, I just like to, turn it in just a -2. It's the same thing though as plus a -2 if you put that here, okay?
But
see-
rather the outcome.
Well, the reason why I like to put just a -2 here is because I know then that if I wanted to move this 2 over to the right side of my equation, I would have to add what, 2? Do you agree? I would have to add 2. But if you put plus a -2 here, then it's a little more mystifying as to what you do to move the 2 over to the right side of the equation. It's a little bit more difficult to understand what you need to do. That's why I just like this. Instead of saying plus a -2, I just like to report it as -2 here.
So
Okay?
if you times it and it's always a negative, we can just drop the positive sign and put the,
like right here, a -1 times a -3.
yeah.
Yeah, a -1 multiplied by a -3. A negative times a negative is a what? Positive, right?
Positive.
Plus.
So you
And
just
1 times 3 is 3. Yep.
Okay.
So -1 times -3 is plus the 3. So Okay. What do we do next? Well, on the left side, we have some like terms that need to be combined. What's a negative 6x subtract 8x? What's negative 6 subtract 8? That's really negative 6 plus a what? Negative 8. Do you agree? Which is what? Negative 14?
Yeah.
So therefore, negative 6x minus 8x is minus 14x, negative 14x. Like terms, negative 2 must be added to 3. What's a negative 2 added to 3? A negative 2 added to 3.
1.
Negative plus 1. It's a plus 1. So the negative 2 plus 3 combined to give you a plus of 1. On the right side of our equation, we have 8 that must be combined with a minus 1. What's 8 subtract 1?
7.
7. There's the 7. There's the 7 right there, right? 8 minus 1 is 7. And then we got the minus 5x. Now, ladies and gentlemen, there's nothing else we can do to simplify both sides. So it's time to separate now. So I'm going to bring my x's over to the left, my constant terms over to the right. The next step in doing that, I decided to subtract 1 from both sides to move this 1 over to the right side to join the 7. The 1's drop out on the left side after doing that. We're left with negative 14x. 7 minus 1 is 6 minus the 5x. Continuing to separate. Now that I got my constants on the right side, I need to move this variable term over to the left side to join the minus 14x. How do you move a minus to the other side of the equation? You have to add it to both sides. So I added 5x to both sides. Now what's negative 14x plus 5x? Just a negative
Negative 9.
9x. And these 5x's what? Drop out here to 0. Negative 5x plus 5x is 0x, leaving you with just 6. Finally, to get x by itself, we just divide both sides by what? By a negative 9. Divide both sides by negative 9. And therefore, x is equal to 6 over negative 9. But do you agree negative 6/9 reduces down to what? Negative 2/3?
Yep.
If we divide top and bottom of this thing by 3, we can take it down to what? Negative 2/3, correct?
Mm-hmm.
All right. So there you go, ladies and gentlemen. We now have solved that equation, and that was the last one, negative 2/3 there. So we'll call this classwork number 1, okay? Classwork number 1. Okay. Let's put that away. Move on. Ladies and gentlemen, what happens if we have an equation that has a bunch of fractions in it? X over 7 minus 5 over 21 equals x over 3 plus 2 over 7. This equation here, what makes it messy is that we have fractions everywhere. But you know what? There's a trick for knocking out fractions. The trick for getting rid of all these fractions is to multiply both sides of this equation by the least common denominator of all your denominators. And by eyeballing all these denominators, 3, 7, and 21, can we think of the smallest number that is divisible by 3, 7, and 21?
3.
Well, you gave me 3. 3 will divide into itself and divide into 21, but 3 does not divide into 7. I need a number here, ladies and gentlemen, that 3 divides into, 7 divides into, and 21 divides into.
21.
Yeah, after some thought, 21 is called the least common multiple or the least common denominator of 3, 7, and 21. Because you agree that 3 divides into 21 evenly, 7 divides into 21, 21 divides into 21. That's your least common denominator. Now here's what we're going to do. I'm going to multiply both sides of this equation by 21. And by doing this, I'm going to get rid of my fractions. Got to multiply all the terms on the right side by 21. And this 21, I'm putting over 1. You can always put any number over 1. It's still the same number. Now, Why am I multiplying both sides by 21? To get rid of all the what? To get rid of all the fractions?
The fraction.
So you're about to see all the fractions disappear here, ladies and gentlemen. 7 divides into itself 1 time. 7 divides into 21 up here 3 times. 3 times x is 3x. Fraction gone. Minus sign. 21 divides into itself 1 time. 21 divides into this 21 up here 1 time. 1 times 5 is 5. Fraction gone. Over here, 21 times x over 3. 3 divides into itself 1 time. 3 divides into 21 7 times. 7 times x is 7x. 21 times 2, 7. 7 divides into itself 1. 7 divides into 21 3 times. 3 times 2 is what? 6. Fraction gone. Everybody see how we knocked all the fractions out?
No, that was really confusing.
All right, we did so by cross canceling, okay? And now suppose you don't like cross canceling. Well, you could have did 21 times x is 21x, and that sits over 1 times 7, which is 7. Here we would have 21 times 5, which I'm not actually going to multiply 21 by 5 because that would be a horrendously large number. And that sits over 1 times 21 or 21. On the right side, 21 times x is 21x, and that sits over 1 times 3 or 3. Here we have 21 times 2, which I'm not actually going to multiply together. I'm going to leave in factored form. We're sitting over 1 times 7. Now, this might be a little easier for you to see. If you don't like cross canceling, or if you can't see it through cross canceling, maybe you can see it through reduction. How does 21 over 7 reduce? How does this reduce? 21 over 7.
7 goes into 21 3 times.
Reduces down to 3x. Do we see that?
Yeah.
What happens to these 21s here? Don't they reduce out?
Mm-hmm.
Leaving us with what? 5? See that there? 21 over 3, how does that reduce? 21 divided by 3.
7.
7x. 21 divided by 7, how does 21 over 7 reduce?
3.
3. But we still got to multiply the 3 by the what? By the 2. Still got the 2 there. So we have 3x minus 5 equals 7x plus what? 6. That's the same thing that I got up here when I cross cancel. But if you can't see cross canceling, ladies and gentlemen, just multiply your fractions together and then reduce them all, okay? You'll get the same result. All right. Do we know where to go from here? Where do we go from here now?
Combining your like term.
Yeah, you can do a lot of things. You can bring the 5 over to the right, or the 6 over to the left, or you can bring the 3x over to the right, or 7x over to the left. You got 1 of 4 choices here. I like to put my constants on the right side and my variables on the left side. So to do that, I'm going to add 5 to both sides to move this guy over to the right side. So let's add 5 to the left, and let's add 5 to the right side of my equation. These 5s cancel out to 0 on the left side, leaving you with 3x. We have 7x, and what's 6 plus 5? Plus 11. Continuing to separate, let's bring the 7x over to the left side. What sign's in front of 7x? I don't see a sign, so it must be understood to be a positive 7x. How do we move a positive to the other side of our equation?
Subtract.
We're going to have to minus off 7x from both sides then. What's 3x subtract 7x? What's 3 minus 7? 3 plus
-4.
7, which is -4, correct? Yeah. So 3x minus 7x is -4x. And that's equal to these 7x's drop out to 0 on the right side, leaving you with 11. One last step now is to divide both sides by what?
-4.
-4. Divide by -4. These -4s reduce down to 1, and 1 times x is x. So x is equal to -11/4, which you cannot reduce. Just leave it like that. And there's your solution. Okay, -11/4. Okay, to recap, we initially had an equation that had a bunch of fractions in it. To get rid of the fractions, ladies and gentlemen, the magic bullet for eliminating all the fractions was the least common denominator of all your denominators. The least common denominator of 3, 7, and 21 is 21. Therefore, I multiplied this term by 21, this term by 21, this term by 21, and this term by 21. In other words, I multiplied both sides of my equation by 21. By doing that, if you can't see it through cross canceling, then when you multiply your fractions together, you'll get it down to this. And then you just reduce all of these down. Reduce them, and all your fractions disappear. And then you can go from there. Then you're back to a type of equation we've been working with for quite some time now. Okay. All right, so I just wanted to show you that. When your equation has a bunch of fractions in it, you can always eliminate the fractions, all of them, if you just multiply both sides by the magic number, which is the least common denominator of all your denominators. It always gets rid of all your fractions. Okay. All right, a little messier because we had fractions, but we did get rid of the fractions, did we not? We wiped them all out, got rid of them all, and our equation was much nicer looking after that. Okay. Any other questions about this problem here, Elizabeth? That's quite a problem, isn't it? Ladies and gentlemen, what happens if our equation has a bunch of decimals in it? Well, decimals are just as messy as fractions. And so I would recommend that when your equation has a bunch of decimals in it, I would recommend that you get rid of the decimals. Just like we got rid of the fractions, we can also knock out all the decimals. So notice there's a lot of decimals in this equation, but I'm going to show you how to solve it by getting rid of all the decimals. I'll get rid of this decimal, and this decimal. You'll see how we do it. So we'll try to solve this equation for x. I got a question for you, ladies and gentlemen. If I multiply a decimal by 10, what happens to the decimal point? If I take 0.6 times 10, does anybody know what we get? What happens to this decimal point when you multiply a decimal by 10? Anybody want to
On it leave,
What's that?
the decimal doesn't be there anymore, right?
Yeah, because look at, we're multiplying this decimal by 10 and there's 1 0 in 10. So that means this decimal point is going to get shifted one place to the right, which turns us into the whole number of what? Of 6. Do you agree? Everybody see that there? Now watch this. If I have the decimal 0.62, and if I multiply this by 100, now my decimal point gets shifted not one place to the right, but what? 2 places to the right. So now my decimal point is going to get shifted 2 places to the right. So 0.62 becomes really just what? 62. Everybody see what's going on here? So if I had 0.62 times 1,000, what would I get? How many places to the right did the decimal point get shifted?
3.
3 places to the right. 1, 2, and we got to add a 0 because there's a third shift to the right. So it'd be 620. So here's the moral of the story, ladies and gentlemen. To get rid of decimals, all we have to do is multiply them by 10 or 100 or 1,000 or by some multiple of 10. By multiplying a decimal by a multiple of 10, that will force the decimal point to shift to the right so many places. Okay. So I have a question for you. Let's come up to our equation that has a bunch of decimals in it. What would I have to multiply both sides of my equation by to ensure that all these decimals become whole numbers?
100.
100. Do you agree? If I multiply this decimal by 100, the decimal point would get shifted 2 places to the right, and this would become a nice 5. If I multiply this by 100, decimal point gets shifted to the right 2 places, and this becomes the nice whole number 7. If I multiply this by 100, decimal point gets shifted 2 places to the right, and I'll have 620. Let's do that. Let's multiply both sides of this equation by 100. Do I multiply this term by 100? Got to multiply this decimal by 100. And we got to multiply the right-hand side by what? 100. All right, what's 100 times 500ths x? This is really 500ths. It would become just what? 5x. Everybody see how the decimal point moves 2 places to the right, turns it into a nice 5? What's 100 times 700ths? This just becomes what? 7. What's 100 times 6.2 on the right? Decimal point gets shifted 2 places to the right. This becomes 620. Look at how we got rid of all of our decimals, ladies and gentlemen. They're all gone. They're all gone because we multiplied both sides by 100 to get rid of every one of them. Okay. Hey, if I multiply both sides by 10, would that be good enough to get rid of all my decimals? If I multiply this by 10, would it be a whole number?
Yes.
Well, look, if I multiply this by 10, the decimal point would get shifted only 1 place to the right. I would still have 0.5, wouldn't I? 0.5. 10's not good enough to get rid of all of our decimals. You got to multiply both sides by at least 100. Okay. Where do we go from here? Help me solve this equation now. Now we're back to a ordinary equation. How do I solve for x?
Distribution
All
first.
right, yes, we're gonna have to distribute here. So we'll have 5x plus 7 times 100 is 700. 7 multiplied by a negative 1x. What's 7 times a negative 1?
-7.
So we got negative 7x, and that's equal to 620 on the right. Back on the left side, can we combine any like terms? What's 5x minus 7x? 5x subtract 7x. What does that give you?
-2x.
Yes, thank you, negative 2x. Now it's time, since we simplified the left side as much as possible, it's time to separate. I already have my variable terms on the left side. Let's move, therefore, this constant 700 over to the right side. How do we do that since it's a plus?
Subtract that.
We must subtract 700 from the left and from the right. The 700s drop out on the left side to 0, cancel out, leaving you with negative 2x. And on the right side, we have 620 subtract 700. What is 620 subtract 700? That's really 620 plus a negative sum that's 700, correct? Which means you have to take the difference. What's the difference of 700 and 620?
Is it a -80?
80, and it would be a what? A negative in this case. You are correct. One last step now is to divide both sides by a -2, and we will have solved this thing for x. Negative 2x divided by -2 on the left side reduces down to just a 1x or just an x. And a negative 80 divided by -2. What's a negative divided by a negative?
Positive.
Always a positive. So this will be positive what? 2 divides an 80, what? 40 times, I believe?
Mm-hmm.
You got your solution. X equals 40. So to recap, what did we do? Since our equation has a bunch of decimals in them, we decided to get rid of the decimals first. To do that, we had to multiply both sides of our equation by 100. By doing that, all the decimals became nice whole numbers. And then we got rid of our decimals, and then we just went from there. Okay. So that's a trick for knocking out fractions and decimals. To get rid of fractions, we multiply both sides by the least common denominator. To get rid of decimals, we multiply both sides of our equation by an appropriate power of 10. That means either by 10 or 100 or 1,000. Okay. And that will always get rid of your decimals. Okay. All right. Let's see. Okay, so. All right, let's see here, got that there. Okay, classwork number 2, Les, I want to see if you can solve some of these. Number 1, I want you to try to solve. Wait a minute, this is classwork number. Yeah, this is number 2, sorry. I want you to solve this one here. Wait a minute, we already did this one. My bad, hold on. Number 1, I want you to solve this one. And I recommend that we get rid of our fractions first, okay? Number 2, let's see if you can solve this one here. Okay, here it is right here. So we got 0.5 x plus 0.2 times 18 minus x equals 5.4. Okay, see if you can solve those 2 equations, ladies and gentlemen. We'll take a look, and we're getting close to wrapping this. Anybody get to solution number one?
I got -3/2.
-3/2. All right. -3 halves. Anybody else get -3 halves? Anybody else get anything different?
I got a -3/10.
Okay, -3/10,
Me too.
-3/10. Okay, well, we'll have to take a look here and see what we got. All right, well, ladies and gentlemen, how do we get rid of these fractions? What's the least common denominator of 2, 3, 6, and 12?
12.
12. So if we multiply both sides by 12, we should be able to knock these fractions out here. Let's see if we can do that. So what I did is I multiplied both terms on the left side by 12 and both terms on the right side by 12. When I did that, if you don't like cross canceling, which you're welcome to use cross canceling, but if you can't see it, then you can just multiply. But I did not actually multiply the 12 and 7 together because it would obscure how I would reduce this. So I left it as 12 times 7 over 6. This is 12x over 2. 12 times 11, I did not actually multiply together because I want to, be able to reduce it easier. And then 12x over 3. Now these reduce. Notice 6 divides into itself once, divides into 12 2 times, and then you're going to have 2 times a 7 here. 2 divides into 12x 6x times. These 12s reduce out to 1s, leaving you with 11. 12 divided by 3 is 4. Okay. So I got rid of all my fractions. And 2 times 7 is 14. Now it's time to separate the variable terms on the left versus constants on the right. To do that, I subtracted, this is a plus 14, so I subtracted 14 from both sides. 14's drop out on the left, -6x remains. 11 minus 14 is -3 plus 4x. Now it's time to bring the 4x over to the left side by subtracting 4x from both sides. -6x minus 4x is -10x. And the 4x is drop out on the right. Finally, we divide both sides by -10 and we get -3 over -10, which is a positive 3/10. Did somebody say -3/10?
Yeah, I said that, but I see what I did.
One little subtle thing there. Little sign there. Well, I mean, hey, -3/10, that was pretty darn close though. I will say that. Not bad, not bad at all. All right, so yeah, it works out to give you a 3/10 in the end. And the key is you might want to get rid of the fractions first. It does make for an easier go of things once you knock all your fractions out and you have a nicer equation to work with. Okay. All right. Finally, number 2. What did anybody get? Number 2?
Can you leave that for a second? I made a mistake. I just want to fix it.
Okay.
Thank you.
All right, go ahead and fix that. While she's fixing that, anybody get number 2's answer?
6.
6? Okay. Anybody else get 6?
I got a weird fraction.
Okay, you got a strange fraction. All right, so 6, strange fraction. Let's see what we got here. Did you correct that mistake?
I'm almost done. Hang on.
All right.
-3 plus 4x. Okay.
Okay. Let's look at number 2, ladies and gentlemen. The key here is you want to probably get rid of these decimals. And what did we have to multiply both sides by to get rid of all these decimals?
10.
10 is good enough, right? You multiply both sides by 10, all these decimals become whole numbers. So let's do that. Let's multiply both sides of the equation by 10. When you multiply 0.5x by 10, it becomes a nice 5x. 0.2 becomes a nice 2 when you multiply it by 10. 5.4 times 10 becomes a nice 54. Then you're gonna have to further distribute the 2 inside the parentheses. 2 times 18 is 36. 2 times negative x is negative 2x. Simplifying the left side by combining like terms. 5x minus 2x is 3x. It's time to separate variable terms on the left side versus constants on the right side. We're gonna move this positive 36 to the right by minusing it from both sides. And then finally, we divide both sides by 3. And yeah, I mean, if you said 6, that should be the result. Now, if you got that funny fraction, do you see where the mistake occurred?
Yeah, I distribute the 2 into the 18, but I didn't distribute it into the negative x.
Yeah, that happens a lot. It's easy to forget, and you're not alone. I mean, I've just seen students just multiply the 2 by only the 18 and forget to also multiply the 2 by the minus the x here. Yeah, that's a common mistake. But yeah, it has to be distributed into both terms. Any other questions about that one, Lizo? All right, we're almost done here. We just have one more thing to deal with. And it's working with what are called formulas. Does anybody plan on taking any science class in the future, or have any of you ever had like a science class, like maybe, I don't know, maybe like in chemistry or physics or something? Anybody go into computer programming?
I have to because of nursing.
Yes, I do
Yeah.
too.
Yeah, you know, in nursing, there's a lot of dosage formulas, you know, that you work with. And oftentimes you're having to manipulate those formulas algebraically before you actually, you know, solve for the problem. And so this last section here, 2.5, is going to address working with what are called formulas in mathematics. Formulas. What is a formula? A formula is an equation it's an equation with 2 or more variables in it. 2 or more variables. And you know, there's a lot of formulas out there in the real world that are being used every day. For instance, ladies and gentlemen, here's a formula. I is equal to P times R times T. Has anybody ever seen this formula before?
No.
Okay, don't worry about it if you don't know what the formula pertains to, because that's not the issue in this section. The issue is, can we solve a formula for a particular requested variable? Presently, this formula is solved for what variable? What variable is this equation solved for? Anybody?
I.
I. We know it's solved for I presently because I is all by itself on one side of the equation. How many different variables we got in this formula?
4.
We have 4 of them: I, P, R, and T. This, ladies and gentlemen, is called a simple interest formula. If you're interested in knowing what it pertains to, it pertains to money. You know, when we take out a loan, we have to pay back the principal, but we also have to pay back what? Some interest. Do you agree? If we have a student loan, we have to pay back interest on that student loan in addition to paying them off the principal. So this is the simple interest formula used in the business world. It's solved for I. What I want to do is I want to turn the tables on this formula here. I want to turn around, ladies and gentlemen. I want to solve this formula for, let's say, time t. How would I solve this formula for t, time? Well, to solve for time, or t, means we got to get t all by itself on the right side of this equation and everything else on the other side. So how do I knock out this P and this R that are being multiplied by T? What's the inverse of multiplication?
Divide.
Here's what we're going to do. In order to solve for T, to get rid of this P and this R here, that are factors with T, we're going to have to divide both sides of our formula or our equation by P and by R. We're going to divide both sides by P and R. Now, what happens to the P on the right side? It reduces to what?
They cancel.
Yeah, they cancel out and we leave behind ones. The R is also reduced out to ones. And what's 1 times T?
T.
Is T. Ladies and gentlemen, T, or time, is really equal to interest I divided by P times R. We have solved that formula for T. Everybody see what just happened there? Initially, the formula was solved for I. I wanted to turn it around and solve it for t, which means we got to get t all by itself, which means we got to knock out these factors of p and r. The inverse of multiplication is division, so in order to get rid of the p and the r, I divide both sides of my equation by p and r. And that renders t all by itself. Any questions how I solve that formula for t? Okay. Anybody maybe thinking about maybe going into computer programming in the future?
Me?
Software design, computer programming. Maybe somebody? All right. If you do go into that field, oftentimes before you present a formula to the computer system, you're having to solve the formula for a particular variable, and then you sit down and program it into the computer. Okay, so knowing how to solve formulas for a variable is a very important skill if you go into software engineering or if you go into computer science or computer programming. All right, let's try another one. Let's try to solve this formula. Suppose I want to solve this formula for C. Presently, what variable is this formula solved for?
A.
It's solved for A, isn't it? Because A is all by itself. Let's turn the tables on this formula and solve it for C. How, ladies and gentlemen, do I get this C by itself? How do I get rid of this plus B here? How do we move that B over to the other side?
Subtract it.
Subtract it.
That's right. We're going to have to minus B from both sides. We subtract B from the left and we subtract B from the right. The left side just remains as A minus B then. And on the right side, these B's cancel out to 0. B minus B is 0. And we're left with what we wanted to solve for, namely C. And we're done. We have solved that formula for the variable C. Do you see how we solve for C, ladies and gentlemen? No pun intended. How we solve for C there. To solve a formula for a variable means we got to get the variable all by itself on one side of the formula. That's what it means to solve for a variable. There's a lot of formulas. Have you ever seen this formula? Anybody? Have you ever seen this formula before?
Yes.
What does this pertain to? Just curious.
Yeah. Is
What's
that for
that?
area?
Yeah, area for what type of geometric shape? You remember?
Is it a triangle?
You're correct. That's the area formula laid on for a triangle. If you have the height of a triangle, this would be like the height or the altitude of the triangle, and this would be the base length of the triangle. If you take 1/2 times the base length times the height, you generate the area of this triangle, the area. All right, but hey, if you didn't know that, don't worry about it, because that's not really the important thing. I want to take this formula, which is solved for what? What variable is it presently solved for?
B and H?
No, it's solved not for B or H. What's it solved for right now?
A.
It's solved for A. Suppose I want you to turn the tables on this formula and solve it for, let's say, B. How would we solve this formula for B? Well, to solve it for B, we got to get rid of the 1/2 and the H, don't we? We got to knock the 1/2 and the H out because we want B all by itself. How do we get B by itself?
So divide by 1/2 H.
Yeah, exactly. Because look at 1/2 is a factor with B, which is a factor with H. The inverse of multiplication is what? Division. So in order to make this 1/2 and H go away to get B by itself here on the right side, we're going to have to divide both sides of our equation by what you said, which is 1/2 H. Got to divide the left side by 1/2 H also, though. Notice the 1/2 on the right side reduces down to 1. The H's reduce out to 1, and we're left with 1 times B, or B. On the left side, we do have a little bit of a messy situation here. We got A divided by 1/2 times H. And when you divide by 1/2, do you agree it's like multiplying by 2? Do we agree with that? So ladies and gentlemen, if you divide by 1/2, like if I have 1 divided by 1/2, 1 divided by 1/2, how do you divide fractions? Change division to what? Multiplication? Flip the second fraction upside down. Do you agree dividing by 1/2 is like multiplying by 2?
Yes.
See what's going on here? Dividing by 1/2 is equivalent to multiplying by 2. So my point is this: A divided by 1/2 is like 2 times A. So we can bring the 2 up in the numerator here. And there we go. We have solved for B. Okay, we have solved for B. Now, I'm going to show you an alternative way we could have solved for B here. First of all, we could have knocked this fraction out by multiplying both sides by what? What's the least common denominator of 2? Just 2?
Mm-hmm.
I could have multiplied both sides of my equation by 2 to knock this fraction out first. Could have done that first. So let's see that. What if we did that? What if we decided to multiply both sides by 2 first? Got to multiply the left by 2. Got to multiply the right by 2. But what happens to the 1/2 over here now? What does this reduce down to? 2 over 2.
One.
This 1. So this is 2A is equal to 1 times B times H. Now, ladies and gentlemen, to get B by itself, we have to divide both sides by what? H, correct? Got to divide the left by H. And do you agree that I get the same answer that I got over here? 2A divided by H is equal to B. So whether you choose to divide both sides by 1/2 H or multiply both sides by 2 first, both ways work. You'll get the same result for B. B is equal to 2A over H. So we have solved that formula for B. We have solved for B. Any questions how we're solving formulas here for a variable? Yeah, if you go into the sciences, this is a survival skill, being able to solve a formula for a variable. It's a very important skill. How about this one? X plus 3y equals 2. If I want you to solve this formula for, let's say, y, how would we solve this formula for y? We got to get y all by itself, don't we, on the left side of our equation, and everything else on the right side. So what do we do first here? How do I solve for y? What's that?
Divide it.
Well, before we divide both sides by 3, let's just move this whole term of 1x over to the right side. How do you move a positive 1x term to the right side of your equation? What's the inverse of plus?
Negative.
Subtract.
Minus. Let's subtract 1x from both sides of our equation. So we subtract x from both sides. The x's drop out on the left side to 0, leaving you with 3y. Now, how do we get y by itself? What's the last move here?
Divide
Divide both sides by what?
y.
Not y, but what? Trying to get rid of the what? 3. 3, yeah. You got to divide both sides by 3. The 3's reduce out on the left side to 1s, and 1 times y is y. And so we have y is equal to 2 minus x over 3. And we have solved that formula for what? For y. You see how we got y all by itself? You know, presently, this formula was not solved for x or y. It was solved for neither x or y. But we solved it for y. Okay? We solved it for y. All right, you try this one. Just everybody try this one. I want you to solve this formula. P is equal to A plus B plus C. I want you to solve this for B. See if you can solve this formula for the variable B. Solve that for B. How would we solve for B?
Are you gonna give us our, some more homework?
Yeah, I will. I'll see if I can come up with your homework this tonight, okay, and then post it. All righty. So
Okay.
2.4 and 2.5, correct, is what we covered tonight.
Yep.
All right. If there are no other questions, you have a great night, ladies and gentlemen. And hopefully I'll see you. In a couple
I
of
am
minutes.
so sorry, real quick. Can I see the classwork too? Because my computer glitched out when we were going over it.
Let's see here. Classwork 2 was right here. Well, I mean, these were the problems, right?
Okay.
And let's see here. Let's see, that was classwork 2. As far as the, let's see. What do I do with my solutions there? Let's see. Oh, yeah, here they are. Okay. So classwork, this was the first equation we solved in classwork 2. We multiply both sides by 12. Did you need to see this here or?
Let's see. I think I wrote that one down. I needed to see two.
Okay, all right. So you need to see problem number 2, where we got rid of our decimals by multiplying both sides by what, 10, correct?
Yeah.
There you go.
All right. Thank you so much.
You're welcome. All righty. Have a good night.
Thank you, you too.
Have a good night.
We'll see you.
Good night.
Any other remaining questions? Any other questions, Bernard? Well, there goes that session. Let's see.